Welcome to another episode of physics class. Now today we will see about a couple of example questions, or rather practice questions for you to solve. I would advise, when I display the question, pause it, try to solve it on your own, and then compare with the solution that I'm giving. So that way you can get a practice as well. All right. Now in this given question 1, it says there are three forces. If you have identified it correctly, the free body force diagram would be, you have the tension acting in this direction, and you've got the weight acting W downwards, and you've got here as the force horizontal component, right? Because it says mass is 10 and the angle that it makes to the vertical is 40 degrees. Question part A question is, write expressions for the vertical and horizontal components of the tension T in the rope. Now here the tension is acting this way, and if you split it into its vertical and horizontal component, you have got, this will be your horizontal component, this is your vertical component, right? Now, if this is 40, then this angle is also going to be 40 degrees, right? So, this is your adjacent side. I told you where the angle is connected, that will be your cos component. So, this is going to be T cos 40, and this will be T sin 40. Right? So, that will be your vertical component will be T cos 40, and horizontal component will be T sin 40. I hope you have identified that part A correctly. Now part B is, use the conditions for equilibrium in the vertical plane to show that the value of T is about 130 Newton. Now the mass of the object is given as 10 kg. So what will be its weight? So 9.81 into, so W is equal to 9.81 into 10. So you'll get 98.1 Newton. So for equilibrium, T cos 40 should be equal to, T cos 40 will be equal to 98.1 Newton. So from here, if you find T, it approximately gives you the value of, so I think you get 128 Newton, which can be rounded off to 130 Newton, and you get that answer, right? Now they've asked you to find the use the horizontal component to determine F. That also is a straightforward calculation. F will be equal to this force, T sin 40 degrees. So T, you can use 128 sin 40 degrees, which will approximately give you 2 SF 82 Newton. Okay, that was a very simple calculation. So here what did we do? What was the principle? It's in equilibrium, hence the vertical and horizontal component of the forces are balanced. So you're taking both vertically upwards, equating it to vertically downwards, and horizontally also you're equating it, right? Alright, question 2, part A was, calculate the resultant force acting on the person. So if you have identified the forces 500 and 400, so it's a very simple straightforward calculation. 500 forward force is greater, so 500 minus 400, which will give you 100 Newton. That's your part A. For part B, question was acceleration of this gear. So you have the mass of this gear given as 78 kilograms. So you just have to apply Newton's second law. Resultant force upon mass. Resultant force is 100 upon 78. So you get 1.3 approximately meters per second square. Right? That also is a very straightforward calculation. I'm sure you would have gotten it correct. Question 3 is related to elevator situation. Now how do you find the resultant force? For part A, now the downward force will be equal to the weight. Now the total weight is given as 22.2 kilonewton, sorry, 1.5 tons, right? The mass is 1.5 tons, so that will be equal to how many kgs? We'll get 1500 kg multiplied by 1000. So mass is known, and we have to find the acceleration, correct? So, and the cable's tension is given as 22.2 kilonewton. So you must convert that. So all these units have to be in SI units. So this will be 200 newtons is the tension. So what will be our equation here? Is raised by a cable. So tension minus W will be equal to the resultant force. That will be equal to MA. This is our equation. Now the tension is 22,200 minus W. W, how can I find out? 1,500 multiplied by 9.81. Now that will be equal to mass into acceleration. Again, we have to include this mass, 1,500 multiplied by A. So we got the equation, and you can find A from here. I think A is approximately 5 meters per second square. Did you get it? So we have calculated, the tension was directly given to you. All we had to do was to convert to SI unit. W we had to calculate because it's a force. Mass is given, multiplied by 9.81. This will give you weight of the lift as a whole, and then substitute in our general equation T minus W, resultant force MA. A could be formed from there, right? Now the B part is related to just the person. So the person's weight is given as, mass of the person is 50 kilogram, and they're asking you, the question says, calculate the normal contact force of the floor of the lift on her feet. Now this, you have to take the person as a single object and think about the forces acting on it. What are the forces? The weight of that person and the contact force on her are the two forces. Since it is accelerating up, the contact force again will be greater. So the contact force minus weight of the person. Here the weight of the person, not the lift. Weight of the person will be equal to mass into acceleration of the person. So all these are related to the person itself, right? So we need to find out this. So W will be equal to minus this weight of the person. How do I find out? 50 mass of the person multiplied by 9.81 will be equal to, again, mass of the person is 50 multiplied by this acceleration we have calculated in the previous one. See, acceleration as a whole is the same for every single object and the lift. So that is 5. It's an approximation. So contact force, if you sum it up all together, you should be getting approximately 740 newtons. So that's the solution for part B. If you're able to solve this question correctly, that means you have understood, the elevator as a whole, and the person, the free body, how to construct the free body force diagram, and how the forces change according to acceleration, deceleration. I hope it's clear for you. Try to practice more questions related to this, and you will get a better understanding. See you in another video. Bye.